In The Hitchhiker's Guide to the Galaxy, a supercomputer spends 7.5 million years calculating the answer to the universe, and it turns out to be 42. But author Douglas Adams never tells us the actual question. I think the question is hiding inside a simple mathematical series. We must first examine how infinity actually behaves in order to understand why 42 could simply be a natural byproduct of the cosmos.
Let's start with a pizza. If I hand you half a pizza, then a quarter, then an eighth, and we keep slicing and adding forever, how much pizza do you actually have? Infinite slices don't mean infinite pizza. Because the slices shrink so fast, the total amount hits a ceiling you can never pass. It equals exactly one whole pie. In math, we call this a converging series. But what happens when a sequence looks like it should hit a ceiling, but breaks the rule instead? Instead of halving our pizza every time, let's just count normally as fractions. 1 plus a half plus a third plus a fourth. This isn't just a random set of numbers. It perfectly models the physical vibrations of a guitar string, which is why we call it the Harmonic Series. Because these fractions get microscopic so fast, your brain tells you the sum has to hit a ceiling. But to prove what it actually does, we have to look at a brilliant trick from the 14th century. In 1350, a scholar named Nicole Oresme noticed a hidden pattern. He realized he could group these fractions together in expanding batches. Look at the third and fourth fractions. 1/3 plus 1/4. Think about it. A third is obviously bigger than a quarter, so if you add them together, the result must be greater than a quarter plus a quarter. It has to be more than a half. He applied this to the next group of 4 fractions. Every number in that group is larger than an eighth. 4 times an eighth? Exactly a half. Every expanding group contributes more than a half to the total, forever. Oresme proved that the harmonic series never stops growing. It diverges to infinity. It's like a bucket with a microscopic leak being filled by a hose that never ever turns off. 300 years later, Johann Bernoulli found another way to prove this. He set a contradiction trap. He said, let's pretend the series does hit a ceiling, and we'll call that total A. He brought in a different set of fractions and showed that every single one could be split into a subtraction problem. For instance, 1/6 is exactly 1/2 minus 1/3. When he added all these split fractions together, something amazing happened. The inner numbers cancelled each other out. The minus halves cancelled the plus halves. The thirds vanished. The fourths vanished. Math calls this a telescoping series. Like a collapsible pirate's spyglass, everything in the middle just folds up and vanishes, leaving only the ends. By repeatedly subtracting from this collapsed series, Bernoulli built a cascading chain of equations. When he added them all up, the right side perfectly reassembled his original finite number, A, but the left side added up to a manipulated version of the exact same series. He arrived at an impossible mathematical contradiction. A equals 1 plus A. The whole equals the part. This impossible equation was absolute proof that the harmonic series never stops, so it grows infinitely. But it grows at an incredibly, almost painfully slow pace, which brings us right back to 42. Our universe is about 13.8 billion years old. Imagine if you built a supercomputer at the exact moment of the Big Bang and programmed it to add one fraction of the harmonic series every single second. What would the total be today? There are roughly 435 quadrillion seconds in the age of the universe. If you plug that number into the series, the sum right now is only about 41.2. We are so close to 42, but not quite there. To hit exactly 42, that supercomputer would need to keep counting for another 17 billion years. Did Douglas Adams secretly know the math just needs more time? Perhaps the ultimate timeline of reality is just a slow harmonic series, still calculating its way toward 42. To really wrap your head around how agonizingly slow this math is, you have to see the data for yourself. I've set up a custom Harmonic Series visualizer on the front page of NumberVibe.com, a utility calculator platform I run. If you type in 10 terms, the graph jumps up quickly, but type in a larger terms, the line practically flatlines. Type in a super large terms, and it barely twitches. You can keep adding zeros all day, and the total hardly moves. Head over to NumberVibe.com to play with the visualizer, and if you love exploring the mysteries hidden inside mathematics, hit subscribe.